That's the final exam review here. There's probably going to be 2 videos because it'll take too long. Solve it analytically, so we need an exact answer here, so add 11 across. To solve an exponential, you need to isolate the exponential, and then to solve it, we're going to use its inverse, which is take the natural log. So this comes down. We have 3x minus 1. Natural log of 2 equals natural log of 10. And we're going to go ahead and solve for that. So divide by natural log of 2. So 3x minus 1 equals this. And this is just a number, but if I'm doing this and getting an exact answer, if I'm going to turn it into decimal, that's fine. You can type it in the calculator that way. So add 1, then divide by 3 or multiply by a third. So this is natural log of 10. The easiest way to write this would be natural log of 10 plus 1 in parentheses, and then multiply by the 1/3 to get rid of the 3, which will get you a decimal there. Okay, type that in the calculator. All right, next one here, solving a log, condense. So this first thing is coefficient comes up, so it becomes 4 squared, which is 16. And then subtraction, of course, is division. So logs subtracted are division, again, because this is truly an exponential. And if we go ahead and use the definition, 5 cubed equals x over 16. So 125 equals x over 16. And so 16 times 25, which is 2,000. And that's your answer there. So again, logs, you got to use the definition, which is turn it into its inverse. Exponentials, you're going to go ahead and take natural log. Growth to decay, 1.08. Compare this to 1. There's nothing in the exponents, so we don't have to do anything funny. So it's just 8% growth because it's bigger than 1. Then other one, 0.29. You solve for r, you're going to get negative 0.71, so 71% decay. E to the 0.03. It's really close to 3%. If you put e to the 0.03 in your calculator, you get 1.03045, so it's around that. So if you compare that to 1, it's 0.0305 or 3.05% on that. And of course, be careful about the one that's like 5 when half-life, and it's, like takes 10 units of time, like 10 days or whatever, or 10 years. And so then you take 1/2 to the 1/10, and then the x is on the outside, that exponential rule. So you put in 1/2 to the 1/10 power, 0.933. So it's losing 50% every 10 years. But if you do that and compare that to for every year, then if you do that, you're going to get 0.067. I think that's my right math. Or 6.7% each year. It'll get you down to half after 10 years. All right, the equation of this. So the base exponential here, b equals y2 divided by y1. Should have that in your formula. So it's a times b, and it's x over whatever the unit of time is here. So it starts with 80. My base is 1/2 because 40 divided by 20 or 40 divided by 80 is 1/2. But it took 3 units of time to become 1/2. Okay. Compound interest, we did a nice job with this on the test. $2,000. Compounded one's annually. So it's just 1 plus 0.04. N is 1 here. We don't need to do that, but in 10 years. So you're going to put that in for 10. The other one is 3%, but it is compound monthly. So 0.03 over 12. And so this exponent is going to become 120. The percent is going to win this one. So this is going to be the larger one here if I type this in my calculator compared to this one. But this is a little better than 3% because it's compounded monthly. All right, next one. Graphing an exponential. This graph has been shifted. It's a growth graph, so that means it's because it's a positive 2, or it's greater than 1 there, so 2 is greater than 1. Our locator point, though, is at 3 from this exponent. So 3, and then it's going to be at 9. So remember, exponentials are the only ones that are tricky like this. So 3, 9. And then the horizontal asymptote, though, is the 5. So that's the horizontal asymptote. So you need to have that. So you need to have the horizontal asymptote. You need to have the locator point, like so. It's growth. So if I wanted to know what the domain was in this, exponentials are all real numbers. That's a fancy R. And in the range, y is greater than the horizontal asymptote, which is 5. Okay. The next one here is a log. Same thing, we need a locator point. Now it's the inverse. So instead of having a horizontal asymptote, it's going to have a vertical asymptote at 3. So this is right 3. And again, it's because it's what makes the inside 0. And so 3. And if logs are funny, you set the inside equal to 1, because that's what makes a log 0, is when the inside's 1. So the locator point here is at 4, 4. And again, I remember this problem. 4, 4. Because if I put in 4 into this, I get log of 1. Log of 1 is 0. 2 times 0 is 0. 0 plus 4 is 4. So I don't like how this is an ambiguous problem, but I need to make sure I have a locator point. Of course, know that a log graph looks like that. And that's a big thing here. Okay. Condense. Exponents come up. All right, the coefficients come up as exponents, and then subtraction, division. You work our way from left to right. And we can only condense because they're the same base here. So this is x to the 5th over 2, and then if I multiply by 6, so 6x to the 5th over 2. I can simplify this to be log of 3x to the 5th, and that's fine on that. Okay, next one. Solve analytically, a little more solve. Divide by 4, so that's 3. So log 3 equals 3. Definitely have this. So 3 cubed is 27. So this is the base, this is the exponent, it's 27. Again, condense. So if I have, I need to get a singular log like I did here. So I need to condense this in order to get a singular log. So 3 squared, because this 2 comes up as squared. So it's 9. 3 squared is 9. So this becomes log of 9x. Okay. And so 5 squared is 9x. So 25 equals 9x. So x is 25 ninths. And that one. Okay, exponential. It's a little easier because it's a natural log that we'll solve this with. Oops, subtract 3, that makes 8. And then divide by 4, makes that 2. Now I'm going to go ahead and take the natural log of both sides. And so if I do that, I can take the natural log. This exponent comes down. So x minus 1 is in parentheses. Natural log of e is 1, so that's nice. And so it's just 1.69, or 1, if I add the 1 across, 1 plus natural log of 2. This is the exact answer on that. If I bought a new van for 25 grand, depreciation of 20%, how long will it take before we're going to solve it graphically. So first, if we need the equation, so 25 grand, 1 minus 0.2 annually, so it's just that, t or x, so it's 25,000.8 t. Your calculator is going to use x, so that's my first equation. Second equation is 10,000. We want to know when it's equal to 10,000, so we're going to graph this, but realize you got to be all the way up. I mean, this window is going to have to, your y max is going to have to be bigger than 10,000 so you can see this part of the graph. This is going to be 4.1 years. All right, and so again, solve them graphically, so you'll need to have your graph. Okay, next one, inverse. So remember, switch the x and y. So x now equals 4 to the y, and we're going to rewrite this in its log format. So remember, the base goes here, the exponent goes over on the other side, and the answer is there. So that's the inverse. Okay, next one, use your calculator. This is the change of base rule. So this, one of the rules is that log of 20 divided by, that I can do log of 20 divided by log of 5, and it's because it's an exponential that this works. You can type it in your calculator, it's 1.86. Okay, this one here, regression equation. So exponential, logarithmic, we're going to check to see which one's better. So you're going to take a look at the scatter plot. And this one here, if you look at it, if you do the zoom 9, it looks very, very exponential. So we need to use our brain to sort of figure out what's it looking like. And the equation is going to be 11 point, I'm going to use 2 decimal places, 29 times 1.09 to the x. That's my equation. My correlation coefficient, R, is 0.958, so it's amazing data. I just made it up. One thing to note is I gave you the x values here. Remember, I talked about, hopefully I talked about in class, that if I have a story problem or time, these are too big of numbers for our calculator. So the year 2000 wouldn't, like if I say let t equal 0 at the year 2000, then you would convert every one to, say 0. So it doesn't have to be, so 2002 would then equal 2. So realize that our calculator can't use this big of numbers for this, so we need to be able to go ahead and convert those into more manageable numbers. All right, so make sure you can do that on your exam. Okay, graphing this quadratic here. Remember, it's what makes the inside 0, so the vertex is at 3, 5. This is in vertex form. Definitely have some graphing. And if I make a table here, 3, 5 is the middle of it. And if I plug in these numbers here, I'm going to get to 1 and 1. If I plug those in, and so nice parabola. That's the first one. So there's definitely some quadratic stuff. Solving this guy here, 2x squared plus 8x minus 7. We can see if it factors, if we want to try to solve it by factoring. Otherwise, use the quadratic formula, which is fine too. So remember, negative b plus or minus a squared minus 4ac all over 2a. If I'm solving, unless it says solve by factoring and it's a trinomial, I'm probably going to go ahead and use the quadratic formula. But you don't have to. See if it factors here, or you can complete the square. Remember, a is 2, b is 8, c is negative 7. So that's how I'm putting those in. So remember, the b is going to get squared. It's always going to turn to a positive number there. So make sure that that's always positive. And I'm glad I did this with quadratic formula because this was not perfect. Square root of 120 all over 4. Now that does reduce. This is great, but if it does reduce, 120, we can break down 120. Remember, if you saw it as 4 times 30, that's even better. But breaking this down to 60, 230, 215, 3, 5, go until you get a 1. And a pair comes out, so that's 2. And what's left gets multiplied together, so that's 30. So a pair comes out as a single 2. So I've got negative 8 plus or minus 2 root 30, 4, which is so nice because each of these numbers are divisible by 2. So it's negative 4 plus or minus square root 30 over 2 here. I don't take it out of the 30 because this whole thing is an entire term. Okay, that's that answer. Okay, remember how to factor here. So I'm going to go ahead and multiply 8 times negative 15. So that's negative 120. And I need two numbers that multiply to be negative 120, but combined to be positive 2. So the only way that that's going to happen is if one's positive, one's negative. The fact that this number is so small means these numbers got to be close to each other, like, 12 times 10. So 12 and 10. So it's going to be 8x squared. Positive 12x, because I want it to be a positive 2, minus 10x minus 15. Then we group. So I'm going to pull out the greatest common factor. In this case, it's 4x. So I'm dividing each of these by 4x. Here, I'm going to pull out a -5. No matter what, if this is a negative, we always pull out a negative. And lo and behold, 2x plus 3, 2x plus 3. So that gives us 4x minus 5. 2x plus 3. That's your answer. Oh, good old imaginary numbers. So distribute. So this is 20 plus 8i plus 15i. And 2i times 3i is 6i squared. But if you recall, I squared is -1. So that's 23i minus 6 now, because I squared is -1, so it's 14 plus 23i. Okay. Okay. So graphing these two, just simply graph and see when they cross. That's the easy way to do it, or you can set them equal to each other and solve it as a quadratic. But in this case, this is a system, so I need an x and a y because it's a system. So that's different than just an equation. Actually must factor nicely when you do this. But if you do this, you get -0.667, or -2/3, and 5 2/3, or 5.6 repeating, I guess is the best way to write that. That's the one answer, because if you graph it, you see something that looks like this. And so you get the one answer, and then you can find the second one. Again, you can solve this algebraically and factor it, but once you get this, your answer, plug it back in, plug it in for x. And then, but when you're using a calculator, you're going to use the second calculate intersect, and you're going to have to go to the closest point to find another one. So like, I need the other order pair, a beautiful one, 313. Okay. All right. So graphing one, definitely take advantage of that if you can do that. X plus 3, x plus 6 factoring. This is just standard one. This is a difference of squares, 4x minus 5. Remember, it's a subtraction. If it was positive, it would not work. And then 4x plus 5, because 4 times 4 is 16. 5 and 5 makes 25. I think I just did this other one, right? Yeah, I just did this one here. See the other page. Okay. This one here, we just got done doing this in our calculator. Being able to do that, so stat, calc 1 variable. There is no mode, I don't think, in this one. If there is, oh, maybe there's a 7.4. Looks like 7.4 is there 3 times, so 7.4 is your mode. So the mean, median, mode. So just put that in your number. 5-number summary, that's the min, etc., first quartile, and median, etc. Make your box and whisker. Make sure that you label down here these numbers that are on your box and whisker. So like, for instance, if you start at 2 and go by 2s, make sure you label these and then put your label on it. Again, a graph without labels is worthless. And so in this case, my label would be minutes, represent hours on a cell phone per day. So hours would be there. And then this up in the title would be students on cell phones, etc., blah, 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 up there. So something along those lines. Okay? All right, I'm going to have a second video here in a second, also for this.